Welcome. Take a deep, slow breath and let the air move through you like a gentle tide. Tonight, we are going to embark on a journey that begins exactly where you are, in the warmth and safety of your bed, but carries you far beyond the horizon, into the deep, velvet quiet of the cosmos. As you settle into your pillows and adjust the covers, imagine the world outside your window beginning to fade. The sounds of the distant traffic, the hum of the house, the lingering thoughts of the day, let them all drift away like mist under a morning sun. We are heading toward the cosmic nursery, those vast glowing clouds of gas and dust, where stars are born in the magnificent silence of the infinite. If my voice helps you find a sense of peace tonight, you might consider gently liking or subscribing to our quiet space here. It is a small, whispered invitation to ensure we can always find our way back to these calm waters of knowledge together whenever you need to rest. The word nebula comes from the Latin word for mist or cloud. In the immense scale of the universe, these nebulae are the cradles of everything we have ever known. To reach them, we must first understand the scale of our journey. Light, the fastest thing in existence, travels at approximately 299,792 kilometers every single second. At that speed, you could circle the Earth 7 times in the blink of an eye. Yet, even at that staggering pace, the distances we will travel are so vast they are measured not in miles, but in the years it takes for light to cross the void. But before we reach the distant stars, we must first leave the embrace of the Earth. Our atmosphere is a thin, protective blanket, a delicate layer of gas that keeps us warm and safe. If the Earth were the size of a simple apple, the air we breathe would be no thicker than the apple's skin. The edge of this blanket, the Kármán line, where the air becomes so thin it essentially vanishes into the vacuum, is roughly 100 kilometers above you. It is a distance you could drive in just an hour if your car could travel straight up toward the moon. For a moment, bring your focus back to the room and the weight of your body pressing against the mattress. Notice how the bed supports you completely without you having to do anything at all. Your feet are heavy, your hands are still, your shoulders are softening, sinking deeper into the fabric. You are safe and you are grounded, even as we begin our slow imaginary ascent. Imagine now that we are rising, lifting away from the gravity of the day. We pass through the soft, cool layers of the clouds, leaving the lights of the cities below until they look like tiny, flickering embers in a hearth. The air grows colder, thinner, and the familiar blue of the sky begins to deepen into a dark, royal indigo. We are approaching the very edge of the world, moving toward the exosphere, where the last traces of Earth's breath meet the endless, silent dark of the vacuum. As we drift further into the exosphere, the very last layer of Earth's embrace, the air becomes so sparse that the individual molecules are sometimes miles apart. It is a strange, beautiful threshold. Below us, the planet is a glowing marble of sapphire and white. But ahead, the sky has transformed. The familiar, comforting blue that we see from a park bench or a bedroom window has surrendered to a deep, velvety black. You may have wondered, while looking at photos of the moon or the stars, why the sky in space is so dark. After all, the sun is right there, a magnificent blazing furnace of light, far brighter than it ever appears from the ground. On Earth, The sky is blue because of a process called Rayleigh scattering. As sunlight enters our atmosphere, it strikes the molecules of nitrogen and oxygen. These tiny particles act like a billion miniature prisms, scattering the shorter, blue wavelengths of light in every direction, filling the dome of the sky with color and obscuring the stars during the day. But here, at the edge of the vacuum, there is nothing for the light to hit. The sun's rays travel in straight, invisible lines, passing through the emptiness without being scattered or diffused. Without molecules to catch and bounce that light toward our eyes, the space between the objects remains a pure obsidian dark. It is a darkness that doesn't feel cold or frightening, but rather like a soft, heavy curtain of velvet that stretches out in every direction, allowing the distant stars to finally shine through with a steady, unblinking light. We have passed the Kármán line now, that invisible boundary 100 kilometers above the surface that scientists use to mark the beginning of space. At this height, the atmosphere is 1,000,000 times thinner than it is at sea level. One of the most peaceful realizations about this place is the absolute nature of its silence. Sound, as we know it, is simply a vibration moving through the air. It needs the touch of molecules to travel from one place to another. In the vacuum of space, where those molecules are absent, sound cannot exist. There are no whistling winds here, no hum of traffic, no distant echoes. It is the most perfect quiet the universe can offer, a silence so deep you can almost hear the rhythm of your own slow, steady breathing. Feel that stillness now. Let it settle over you as we move further away from the Earth's gravitational pull. The weight of the world is literally lifting. The tug of the planet that holds the oceans in place and keeps our feet on the ground is growing fainter with every passing mile. We are shedding the heaviness of the day, the week, and the year. As we drift into the silent reaches, the Earth begins to shrink behind us, and our eyes adjust to the new, shimmering landscape of the deep void. Ahead of us lies the vastness of the interstellar medium, the great quiet stretches of space that lie between the stars, waiting for us to explore their hidden secrets. We are now drifting into the true deep, leaving the last wisps of Earth's atmosphere behind as we enter the vast, silent stretches between the stars. This is the interstellar medium, the great quiet sea that fills the gaps within our galaxy. To our eyes, it looks like a perfect void, an endless expanse of absolute nothingness. It is easy to imagine that if we reached out our hands, we would touch only the cold, dark vacuum. But the universe, in its quiet complexity, rarely deals in absolute emptiness. Even here, in the loneliest reaches of the galaxy, space is alive with a very thin, very delicate presence. It is a cosmic mist so fine that it makes the clearest mountain air on Earth seem thick and heavy. If you were to take a small container, perhaps the size of a sugar cube, and hold it out into this void, you would likely find only a single atom of hydrogen floating inside. To put that into perspective, a single breath of air on Earth contains billions upon billions of molecules. Here, the atoms are so far apart that they may travel for years before ever bumping into one another. It is a loneliness of a different scale, a solitude that spans light years. Most of this nothingness is composed of individual atoms of hydrogen, the simplest and oldest element in the universe. Along with these atoms, there are microscopic grains of dust no larger than the particles in a puff of smoke. These tiny pieces of carbon and silicates are the remnants of stars that lived and died long before our solar system was even a thought. They drift through the dark like tiny frozen messengers, carrying the history of the cosmos in their silent transit. As we float through this medium, the temperature is unimaginably low. In the deepest parts of this interstellar sea, far from the warmth of any sun, the temperature hovers just a few degrees above absolute zero, the theoretical point where all atomic motion ceases. It is a chill that is not biting or harsh, but rather a profound, still cold that preserves everything it touches. And yet, through this cold and empty space, invisible energies are constantly at work. Cosmic rays, high-energy particles accelerated by distant supernovae, streak through the vacuum at nearly the speed of light, silent and unseen, weaving a web of energy across the galaxy. Take a slow, deep breath and imagine yourself as part of this quiet drift. You are weightless, suspended in a place where time seems to stretch and slow. The frantic pace of the world you left behind is now just a flickering memory, replaced by the rhythmic, steady pulse of the deep cosmos. As your eyes continue to adjust to the darkness, you begin to notice that the blackness ahead is not entirely uniform. There is a soft, almost imperceptible change in the texture of the night. On the distant horizon of our journey, a faint ghostly light is beginning to bloom. It isn't the sharp pinprick light of a single star, but something much larger and more diffused. It looks like a delicate veil of color, a smudge of glowing ink dropped into a pool of clear water. We are approaching our first great celestial landmark, a place where the thin gas of the interstellar medium begins to gather, thicken, and glow with the light of its own. We are moving toward the heart of a nebula, a cosmic nursery, where the story of life truly begins. As we continue our silent drift, the faint ghostly smudge we glimpsed on the horizon begins to expand, revealing itself as a majestic cathedral of light. This is the great Orion Nebula, a place of profound beauty and quiet power. From our distant home on Earth, it appears as a modest fuzzy star in the sword of Orion the Hunter, but as we approach, its true scale begins to dawn on us. It is a structure of such immense proportions that it humbles the very idea of distance. Take a moment to settle deeper into your pillows as we consider the sheer magnitude of this celestial cloud. The Orion Nebula is approximately 24 light-years across. To cross it from one side to the other, even at the incredible speed of light, would take 24 years of constant travel. It is a vast, three-dimensional wilderness of gas and dust, a sprawling nursery where new worlds are currently being knit together in the dark. It is curious to think that something so massive can appear so small to the naked eye on a crisp winter night. If you look just below the three iconic stars of Orion's belt, you might see a tiny misty patch. It looks fragile, almost like a thumbprint on a window pane. You might wonder how a cloud that could hold thousands of solar systems could be reduced to such a tiny speck. The reason is the staggering depth of the space between us. The Great Orion Nebula sits about 1,344 light-years away. The light reaching your eyes tonight began its journey toward Earth long before modern technology, traveling through the vacuum for over 13 centuries just to meet your gaze. If this nebula were closer, say just a few dozen light years away, it would dominate the night sky, stretching from horizon to horizon like a glowing, multicolored aurora that never fades. But at its current distance, it remains a quiet, distant wonder, a secret revealed only to those who linger in the dark. As we cross the threshold and enter the nebula's outer reaches, the velvet blackness of space begins to soften. We are no longer in the empty void. We are submerged in a sea of translucent color. The grayish mist we saw from afar is transforming. It's as if we are diving into a pool of liquid light, where the very atoms of the universe are beginning to glow. The air around us, if we can call it that, is becoming thick with the presence of ancient elements. The first color to greet us is a deep, resonant shade of red, a warmth that seems to vibrate in the stillness. It is the signature of the most abundant element in the cosmos. And as we drift deeper into its embrace, we begin to understand the chemistry of this celestial glow. As we drift further into the heart of the Orion Nebula, the surrounding space begins to blush. It is a soft, deep crimson, the color of a fading sunset or the embers of a dying fire. This is the realm of hydrogen, the simplest and most abundant element in the universe. Within these vast clouds, the hydrogen isn't just sitting quietly. It is alive with energy. We call these emission nebulae because the gas itself is generating its own light, radiating from within like a soft celestial lamp. Imagine a neon sign on a quiet, rain-slicked street. Electricity surges through the gas inside the glass tube, causing it to glow with a specific vibrant color. A nebula works in much the same way, though on a scale that defies imagination. Nearby, massive young stars are pouring out intense ultraviolet radiation. This energy strikes the hydrogen atoms, stripping away their electrons in a process called ionization. When those electrons eventually find their way back home to their atoms, they release a tiny burst of energy in the form of light. In the case of hydrogen, this light is most often a very specific shade of red, known to astronomers as H-alpha. It is a cosmic heartbeat, a steady rhythmic glow that defines the look of the stellar nursery. You might wonder, if you were floating here in person, would your eyes see this same vivid tapestry of pinks and reds? It's a natural curiosity to have as you settle into the stillness of your room when we look at the breathtaking photographs from the Hubble or James Webb telescopes. We see a riot of color that seems almost too beautiful to be real. The truth, however, is a bit more subtle. Human eyes are not very sensitive to color in low light conditions. If you were truly here, drifting through the nebula, much of it would likely appear to your naked eye as a ghostly, ethereal, gray, or perhaps a very faint, washed-out green. Our eyes evolved to see in the bright light of a sunlit Earth, not the dim, distant reaches of deep space. The vibrant images we see in books and in screens are often what scientists call representative color. This doesn't mean the colors are fake. Rather, they are captured over long exposures to reveal what is truly there. even if our eyes are too limited to perceive it in the moment. By assigning specific colors to different elements, red for hydrogen, green for oxygen, or blue for sulfur, astronomers can map the structure of the nebula and understand its hidden chemistry. It is a way of translating the invisible language of the universe into a visual symphony that we can appreciate. Even though the gas appears like a soft, cool mist, it is surprisingly energetic. In the regions where the hydrogen is glowing most brightly, the temperature of the gas can reach 10,000 degrees Celsius. However, because the gas is so incredibly thin, far more a vacuum than any air we breathe on Earth, it wouldn't feel hot against your skin. It would simply feel like a vast, open stillness, a warm glow for the mind rather than the body. As we continue our slow, weightless journey through this cathedral of light, the dominant reds begin to shift. The warm crimson glow starts to mingle with something cooler and crisper. We are moving away from the regions of glowing ionized gas and toward areas where the light behaves in a different, more delicate way. Ahead of us, the mist is turning a soft, icy blue, reflecting the light of distant stars like a mirror made of stardust. As we drift further, the warm crimson of the hydrogen clouds begins to recede, giving way to a cool, ethereal blue. It is a transition that feels like moving from the warmth of a glowing fireplace into the crisp, moonlit air of a calm winter night. This is the realm of the reflection nebula, where the light doesn't come from the gas itself, but from the stars nearby, bouncing off vast clouds of cosmic dust. To understand this soft glow, think of a car's headlights on a foggy evening. You don't just see the light at its source. You see a soft, glowing halo in the air around it. The tiny droplets of water in the fog catch the light and scatter it in every direction, making the air itself seem to shimmer. In the vastness of space, the process is very similar, though the fog here is made of something much older and more exotic than water. You might find yourself wondering why this region is such a striking icy blue, while the areas we just left were so deeply red. The answer lies in a beautiful bit of physics known as light scattering. This space dust isn't like the dust you might find on a bookshelf. It is composed of microscopic grains of carbon, similar to graphite or soot, and silicates, which are essentially tiny flakes of rock or sand. These particles are incredibly small, often less than a micrometer across, which is much thinner than a human hair. When the brilliant white light from a bright star hits these tiny grains, it doesn't just pass through. Because the dust particles are so small, they interact more strongly with the shorter wavelengths of light. In the visible spectrum, blue light has the shortest waves. These waves strike the dust and are deflected, bouncing around the cloud until they eventually reach our eyes. The longer red wavelengths, however, tend to sail right through the gaps between the dust grains without being disturbed. This is the same reason our sky on Earth looks blue during a clear day. The atmosphere scatters the blue light from the sun more effectively than the other colors, filling the dome above us with color. In the deep vacuum of space, this scattering creates sapphire-colored veils that seem to hang suspended and weightless in the dark. One of the most famous examples of this is the Pleiades star cluster, often called the Seven Sisters. If you were to look at them through a powerful telescope, you would see these brilliant young stars wrapped in a shimmering blue cocoon of light. Interestingly, the stars and the dust aren't actually related. They are simply travelers passing through a cold cloud of interstellar material, illuminating it as they go, like lanterns moving through a misty forest. The blue glow is peaceful, a gentle, cooling light that doesn't demand your attention, but invites you to linger in its stillness. It feels light, airy, and vast, providing a sense of quiet clarity. But as we continue to float through this celestial landscape, we begin to see the light change once more. The blue haze starts to thin, and ahead of us, great towering silhouettes begin to rise against the background of stars. We are leaving the illuminated clouds behind and drifting toward the silent, heavy shadows of the dark nebulae, where the light is finally swallowed by the density of the deep, cold void. As we drift further into the Orion molecular cloud complex, the vibrant blue light of the reflection nebula begins to fade, replaced by a deep, velvety darkness. Rising up against a backdrop of glowing crimson gas is a shape so familiar, yet so mysterious: the silhouette of the Horsehead Nebula. Known to astronomers as Barnard 33, it stands like a chess piece carved from ink, its dark profile etched sharply against a curtain of soft, stellar light. To first glance, it looks like a hole in the universe, an empty void where the stars have simply vanished. But as you settle deeper into your pillows, let your mind rest on the reality of this shadow. It isn't an absence of matter. In fact, it is quite the opposite. These dark nebulae are some of the densest places in all of space. What we are seeing is a thick, opaque wall of cold gas and dust, so tightly packed that it completely blocks the light from the stars behind it. In astronomy, this is called extinction. It is a beautiful, quiet word for the way these clouds swallow the light, hiding the secrets of the cosmos within their folds. You might wonder what lies behind that dark curtain, or what is happening inside the heart of that shadow. Hidden from our eyes are hundreds of young stars and planetary systems, currently invisible to us because their light cannot pierce through the heavy shroud of the cloud. The environment here is unimaginably cold. These dark molecular clouds are among the most chilled places in the galaxy, with temperatures hovering just 10 to 20 degrees above absolute zero. That is roughly minus 440 degrees Fahrenheit. It is a stillness so profound that even the atoms themselves barely move. This extreme cold is necessary. It allows the gas to settle and stay calm, undisturbed by the frantic energy of heat. In this deep freeze, the molecules can huddle together, growing heavier and more concentrated. Take a slow, deep breath now. Feel the weight of your body pressing into your mattress, much like the weight of these dense clouds pressing inward on themselves. There is a safety in this darkness, a quiet preparation for something new. Within these cold, dark towers, the very building blocks of the future are being stored, waiting for the right moment to awaken. As we float closer to the densest core of the Horsehead, we begin to feel a change in the environment. The silence is no longer just empty, it is expectant. The stillness is about to give way to a very slow, very gentle motion. the first pull of a force that has governed the universe since the beginning of time. In the absolute stillness of this dark nursery, a very quiet force begins to make itself known. It is the gentle, persistent pull of gravity. Imagine it not as a sudden tug, but as a soft invitation, a whisper that travels from one atom of hydrogen to another. For billions of years, these atoms may have drifted apart, but now they begin to turn toward one another. Within the heart of the cloud, the gas begins to fold in on itself, like a soft velvet blanket being tucked in around the edges. It is a strange and wonderful thing to consider, how something so light, so airy, and so ethereal as a cloud of gas can eventually become a massive, glowing star. To our human minds, gas is something that escapes, something that disappears into the air. But here, in the vastness of the cosmos, gravity is the master architect. It gathers the scattered mist and begins the long, patient process of assembly. This moment of transition is known to scientists as Jeans instability. It is named after the British physicist James Jeans, and though the name sounds technical, the concept is as simple as a playground seesaw. Every cloud of gas has an internal pressure, a natural tendency to expand and drift away. But when a cloud becomes cold enough and dense enough, its own gravity becomes stronger than that outward pressure. The balance tips. The cloud loses its ability to support its own weight, and it begins a slow, graceful collapse inward. As you lie there, feeling the steady, familiar pull of the earth beneath you, you are experiencing that same fundamental force that builds the stars. In the nebula, this collapse doesn't happen in a flash of light or a sudden roar. It is a journey that takes millions of years. It is a slow-motion descent, a gathering of mass that happens over eons of quiet time. Within these larger clouds, astronomers often find small, dark, isolated pockets of dust called Bok globules. They are named after the astronomer Bart Bok, who first suggested they were the cocoons of future stars. These globules are like cosmic seeds, small, opaque, and silent. They are the densest parts of the nebula where gravity has already won its quiet battle. Inside a Bok globule, the gas is falling toward a single point at the very center. As the atoms are packed closer and closer together, they begin to bump into one another more frequently. The vast, cold emptiness is starting to change. We are moving away from the frozen exterior and drifting toward the very core of this gathering mass. Here, in the deep center, the motion creates a tiny bit of friction, and for the first time in millions of years, the temperature begins to climb. The cold is fading, replaced by a soft internal warmth as the heart of the cloud begins to stir. Deep within that gathering warmth, a new entity is beginning to take shape. It is a glowing, pulsing heart, buried beneath layers of thick, protective dust, hidden from the rest of the universe like a secret. As the density at the center of our collapsing cloud increases, the atoms of hydrogen are no longer drifting through the void. They are colliding. Thousands of times every second, these tiny particles rub against one another, and this constant friction creates a radiant internal heat. This is not the heat of a fire as we know it on Earth, but the heat of gravity itself. It is the energy of falling, converted into the energy of warmth as you breathe in and out, slowly and deeply. Imagine that warmth spreading through the core of the cleared. At this specific stage of its life, the object is what astronomers call a protostar. You might wonder if this is the moment the star is born, but we are not quite there yet. A protostar is a pre-star, a celestial infant still in its cradle. It is bright and it is hot, but it is still gathering its strength. It is still eating, using its gravitational pull to vacuum up the remaining gas and dust from the nebula around it. It is a period of quiet growth, a long, slow accumulation of mass that can last for hundreds of thousands of years. As this protostar pulls more material toward its center, a beautiful physical transformation begins to occur. In the silence of space, the cloud begins to spin. This happens because of a principle called the conservation of angular momentum. It is the same reason a spinning ice skater moves faster when they pull their arms in close to their chest. As the vast cloud shrinks from light years across down to the size of a solar system, its rotation accelerates. What was once a lazy drifting mist is now a graceful, steady swirl. Because of this spinning motion, not all the gas falls directly into the protostar. Instead, much of it flattens out, forming a wide, rotating ring known as an accretion disk. From a distance, it looks like a glowing, ethereal pancake of dust and gas orbiting the central heart. This disk is a place of profound potential. It is the nursery where planets may eventually form from the leftovers of the star's birth. But for now, the focus remains on the center. The protostar is becoming heavier and heavier, and the pressure at its core is reaching levels that are difficult to imagine. The heat is no longer just a soft glow. It is climbing toward millions of degrees. The atoms at the very center are being packed together so tightly that they are beginning to lose their individual identity, pressed into a state of extreme agitation. The darkness of the original nebula has been completely replaced here by a deep amber light. The protostar is almost ready. It has gathered its mass, it has found its rhythm in the spin of its disk, and it is waiting for the final transition. We are approaching the moment of the spark, the threshold where the gathering heat of 1,000 centuries finally ignites into something much more powerful. The moment of the spark has arrived. In the heart of that swirling dark cloud, the temperature has finally reached a staggering tipping point, 15 million degrees Celsius. It is a heat so intense that the very nature of matter begins to change. This is the first breath of a new sun, the beginning of a process called nuclear fusion. Imagine the atoms of hydrogen, which have been drifting through the cold silence for eons, now being pressed together with such unimaginable force that they can no longer remain separate. They are forced to merge, two becoming one, transforming into helium. In that tiny microscopic union, a burst of pure energy is released. This is the power that lights the universe. It is not a fire like we know on Earth, which requires oxygen to burn. Instead, it is a cosmic engine, fueled by the sheer weight of the star itself. As millions of these fusions happen every single second, the star begins to glow with a steady internal light. It is no longer just a gathering of dust. It is a living sun. But as this incredible energy pushes outward, a delicate question arises in the silence of space. If gravity is so powerful that it can crush atoms together, what is to stop it from continuing that crush until the star collapses entirely. This is where we find one of the most peaceful and perfect balances in all of physics: hydrostatic equilibrium. Think of it as a deep, steady breath that the star will hold for billions of years. On one side, gravity is pulling every atom inward toward the center, trying to make the star smaller and smaller. On the other side, the intense heat and light from the nuclear fusion in the core are pushing outward, trying to expand the star into the void. These two titanic forces meet and find a perfect middle ground. They cancel each other out, creating a state of serene stability. The star becomes a solid, glowing sphere, neither growing nor shrinking, but held in a gentle, radiant stasis. When a star reaches this state of balance, astronomers say it has entered the main sequence. This is the long, stable summer of a star's life. It is the phase our own sun is in right now, and it is the most enduring part of a star's journey. It is a time of consistency, where the light remains steady and the heat remains constant, providing a reliable source of energy for the vast neighborhood around it. As you lie there, feeling the steady rhythm of your own breathing, you can imagine the star finding its own rhythm. The chaotic, violent collapse of the nebula has settled into a focused, rhythmic pulse of energy. The star is born, and its first act is to announce its presence to the darkness. This new light is no longer trapped inside a thick shell of dust. It begins to radiate outward, its photons beginning a journey that will take them across the galaxy. This new light has a profound effect on the nursery that created it. The soft amber glow of the protostar is replaced by the brilliant piercing white or blue light of a true sun. This radiation begins to wash over the remaining clouds of gas and dust that still linger nearby. Like the first rays of morning sun hitting a fog-covered valley, this stellar light begins to interact with the nebula in new and beautiful ways. The heat from the newborn star begins to warm the surrounding gas, and the pressure of its light begins to push against the very clouds that gave it life. The silence of the cosmic nursery is about to be filled with a gentle, celestial wind. Imagine a morning lake where a thick, white mist clings to the surface of the water, hiding everything beneath its heavy blanket. As the sun rises, a soft, barely perceptible breeze begins to roll across the hills. Slowly, the mist begins to swirl, thinning out in patches, revealing the deep blue of the water and the green of the reeds. In the vastness of the cosmic nursery, something very similar is happening. This newborn star is now exhaling. It produces what astronomers call stellar winds, a constant outward stream of charged particles moving at incredible speeds. Along with this wind comes radiation pressure. It is a strange and beautiful thought to realize that light itself has a physical weight, that photons, as they strike the surrounding gas, can actually push it away, like a gentle hand moving a silk curtain. As these stellar winds and the pressure of light begin to work, the thick, opaque fog of the nebula starts to clear. The star is carving out a hollow space for itself, a bubble of clarity in the center of the chaotic cloud. This is the moment when the star truly becomes visible to the rest of the universe. It is no longer a hidden secret, it is a radiant beacon. In this early active stage of life, these young suns are often called T-Tauri stars. They are energetic and slightly unpredictable, like a fire crackling softly in a hearth. occasionally throwing off a small spark as they settle into their long-term stability. But you might wonder in the quiet of your mind, what becomes of all the material that didn't make it into the star? Not every atom of hydrogen, not every speck of silicate dust is consumed by the sun's birth. As the stellar wind clears the surrounding area, a portion of this leftover gas and dust begins to settle into a flat, rotating ring around the star's middle. This is known as a protoplanetary disk. From a distance, it looks like a delicate, glowing halo of soft amber light circling the young star like a protective ring. Within this disk, the story of a new world begins. It starts with something as small and familiar as the dust motes you might see dancing in a sunbeam in your bedroom. These microscopic grains of dust made of carbon and ice and rock begin to collide. In the stillness of the disk, they don't bounce off each other. Instead, they stick. Through a process of electrostatic attraction, the same force that creates a bit of static on a warm blanket, these tiny specks form larger clumps. Over millions of years, these clumps grow into pebbles, then boulders, and eventually they gain enough mass for gravity to take over, pulling them together into the seeds of planets. Everything we know, the ground beneath us, the mountains, the very air we breathe, began then as this leftover dust in a clearing nebula. It is a peaceful realization to know that even the remnants, the things that weren't part of the main event, are used to create something beautiful and complex. The star and its planets are a family, born from the same cloud, separated and shaped by the clearing breeze of stellar light. It is a slow, methodical process, a cosmic recycling that ensures nothing is ever truly wasted. Now, as we drift further through the thinning clouds, we see a structure that stands like a monument to this process. It is one of the most famous sights in the entire cosmos, a place where the clearing of gas and the birth of stars are captured in a moment of majestic scale. We are approaching the Eagle Nebula, and rising before us are three towering columns of cold, dark gas, silhouetted against a backdrop of brilliant, ethereal light. These are the pillars of creation, standing tall in the silent void. As we float here, the three towers of the pillars of creation loom before us, bathed in a soft, ghostly glow. They look like ancient weathered fingers reaching up toward the stars, or perhaps like majestic sea creatures rising from the depths of a dark, celestial ocean. Though they appear solid, like mountains of stone, they are actually composed of incredibly cold, dense clouds of molecular hydrogen and microscopic dust. This is the heart of the Eagle Nebula, also known by astronomers as Messier 16. The scale of these structures is almost impossible to grasp from our earthly perspective. The tallest pillar on the left is roughly 4 to 5 light years high. To help your mind settle into that vastness, consider that the distance from our sun to the very nearest star, Proxima Centauri, is about the same length. If you were to travel at the speed of a commercial airplane, it would take you millions of years just to fly from the bottom of that single pillar to its peak. Yet here, in the quiet of our journey, they look like delicate sculptures etched against the velvet blackness of space. There is a strange, beautiful mystery surrounding these pillars. When we look at them through our telescopes, We are seeing them as they were approximately 6,500 years ago, because that is how long it has taken their light to reach our eyes. In the world of astronomy, every view is a look into the past. Some scientists believe that a nearby supernova, the explosive death of a massive star, may have sent a shock wave through this region thousands of years ago, potentially toppling these great towers. If that is true, the pillars might already be gone, dispersed into a chaotic mist. But because of the slow, steady pace of light, we won't know for another 1,000 years. They exist for us as a beautiful light echo, a memory of a structure that may have already returned to the void. As you breathe in slowly, imagine the gentle forces at work on these pillars. They are being shaped by a process called photoevaporation. Nearby, there are massive, hot young stars that act like a cosmic wind blowing intense radiation toward the gas. This radiation acts like a warm sun on a block of ice, slowly carving and eroding the pillars, smoothing their edges and pushing the gas away. This erosion is what reveals the tiny dense knots of gas at the tips of the pillars, where new stars are still trying to form, protected for a little while longer by the shadows of the dust. It is a slow, graceful destruction, a transformation that reminds us that nothing in the universe is truly static. Even these giants are moving, changing, and eventually fading. But as one wonder begins to dissolve, others reveal themselves in even greater proportions. We leave the Eagle Nebula now, watching the three fingers of gas shrink into the distance, becoming just another shimmering patch of light in the sea of stars. We are moving towards something even more expansive, a region of space that defies the limits of our imagination with its sheer size and chaotic beauty. Ahead of us, the horizon begins to glow with the fierce, brilliant light of the Carina Nebula, a place where the scale of creation reaches its most magnificent heights. As we drift further into the deep south of the celestial sphere, the darkness begins to ripple with a fierce, complex energy. We are entering the Carina Nebula, a place of chaotic beauty that makes almost everything else in the galaxy seem small by comparison. If the Orion Nebula was a grand cathedral, the Carina Nebula is a sprawling, infinite mountain range of light and dust, spanning over 300 light years from end to end. It is one of the largest and brightest diffuse nebula in our sky, a massive nursery where stars are not just born, but forged in the most extreme conditions imaginable. It is difficult for our minds to grasp a scale this vast. Consider our own solar system, the distance from the sun to the furthest reaches of the planetary orbits. Now, imagine that distance repeated thousands of times over. The Carina Nebula is 4 times larger than the Great Orion Nebula, and its glow is even more intense. It is so massive and brilliant that it is easily visible to the naked eye from the southern hemisphere, appearing as a soft, luminous patch tucked within the silver river of the Milky Way. At the heart of this turbulence sits a legend of the cosmos, the star system known as Eta Carinae. This is not just a star. It is a stellar titan, one of the most massive and unstable stars known to science. It is at least 100 times more massive than our sun and glows with the staggering intensity of 5 million suns. In the mid-1800s, this star underwent a massive eruption, briefly becoming the second brightest star in the entire sky, before fading back into its veil of dust. This event created the Homunculus Nebula, a small two-lobed cloud within the larger Carina, shaped like a glowing cosmic hourglass. Nearby, we see structures that look as though they were pulled from a dream. There is a region known as the Mystic Mountain, where pillars of gas and dust rise 3 light-years high into the void. From our vantage point, they look like craggy, majestic peaks shrouded in a celestial fog. These peaks are being slowly sculpted and eroded by the light of the very stars they are trying to create. It is a landscape of constant motion and transformation, yet from where we float, it feels perfectly still, a frozen moment of eternal creation. Take a slow, deep breath and let the sheer scale of this place settle over you. Sometimes the vastness of space can feel overwhelming, but try to see it instead as a peaceful, protective blanket. You're a part of this grand design, held safely in the quiet, steady rhythm of the universe. The same forces that carve these mountains of gas are the same forces that allow you to rest and breathe right now. Feel the weight of your body supported and still as we leave the chaotic fires of Carina behind. We are heading now toward a much more solitary, quiet corner of the deep where a single, hauntingly beautiful eye watches over the silence. As we drift away from the turbulent mountains of the Carina Nebula, the cosmic landscape begins to thin out, leaving behind the chaotic fires of star birth for a region of profound solitary stillness. Ahead of us, emerging from the deep indigo of the void, is a sight both haunting and deeply serene. It is often called the Eye of God, though its scientific name is the Helix Nebula. It looks like a giant iridescent eye gazing across the light years. A wide, glowing iris of crimson and gold surrounds a deep, dark pupil. From our vantage point, it feels as though the universe itself is watching over us with a calm, unblinking gaze. There is no noise here, only the soft, radiating glow of gas expanding into the emptiness. This structure is what astronomers call a planetary nebula. The name is a bit of a historical accident, a gentle reminder of how much our understanding has grown. Hundreds of years ago, when the first astronomers looked through their simple flickering telescopes, these round glowing objects looked a bit like the distant planets Uranus or Neptune. We now know they have nothing at all to do with planets. They are something much more poetic. What you are seeing in the helix is not the birth of a star, but a gentle retirement. It is the future of our own sun, billions of years from now. When a star of a certain size reaches the end of its life, it does not always go out in a violent world-shaking explosion. Instead, it enters a quiet phase of shedding. Like a tree losing its leaves in the cool of autumn, the star gently puffs its outer layers of gas into the surrounding space. It is a slow, rhythmic exhale that lasts for tens of thousands of years. At the very center of that dark pupil sits the star's heart, a tiny, incredibly dense core called a white dwarf. It is no larger than the Earth, yet it holds the mass of an entire sun. This white dwarf no longer creates energy through fusion. It is simply the hot ember left behind after the fire has gone out. It glows with a fierce white-hot intensity, and it is this ultraviolet light that illuminates the discarded layers of gas, making the nebula shine like a neon sign in the dark. The Helix Nebula is one of the closest examples of this process, located only about 650 light-years away. Within its glowing rings, there are thousands of comet-like structures, tails of gas stretching outward like delicate eyelashes. These cometary knots are shaped by the intense winds blowing from the central star, each one a testament to the star's final, fading strength. It is a masterpiece of symmetry and balance, a quiet ghost of a star that once was. But the universe is rarely uniform. While the helix takes the shape of a perfect circular eye, other stars leave behind different kinds of ghosts. As we continue to drift through the silence, the shapes begin to shift and stretch, moving from perfect circles into something more complex and delicate. We are moving now toward a structure of incredible elegance, where the remains of a dying star have been sculpted into the form of wings. Out of the velvet darkness, a new shape begins to emerge. It is delicate, graceful, and impossibly fragile in appearance. This is the Butterfly Nebula, known to astronomers as NG 6302. As you drift closer, you can see why it earned its name. Two magnificent, shimmering wings of gas stretch out across the void, looking like frayed silk or the dusting of iridescent color on a real butterfly's wing. These wings are not small. They span over 2 light-years, a distance so vast it is difficult for the mind to truly hold. Take a slow, deep breath and imagine the symmetry of this celestial creature. Unlike the circular, eye-like shape of the Helix Nebula we just left behind, the butterfly is elongated and complex. You might find yourself wondering why it took this specific form. If the dying star at the center is shedding its layers, shouldn't they expand outward in a perfect even sphere like a bubble? The answer lies in a cosmic dance of physics and hidden partners. Deep within the center of those wings, obscured by a dense bridge of dark dust, is a star that has become incredibly hot. In fact, it is one of the hottest stars known in our galaxy, with a surface temperature reaching a staggering 250,000 degrees Celsius. For comparison, our own sun's surface is a relatively cool 5,500 degrees. This intense heat is part of the story, but the shape comes from the way the gas is funneled. Scientists believe that this star was not alone. It likely had a companion, a binary partner. As the primary star began to shed its outer layers, the gravity of the second star and the influence of powerful magnetic fields acted like a tight belt around the middle of the nebula. This belt of dust and gas prevented the material from expanding outward at the equator. Instead, the gas was forced to stream out from the top and bottom at incredible speeds, creating the beautiful bipolar wings we see today. The gas in these wings is moving away from the central star at more than 600,000 miles per hour, even at such a frantic pace. Because the nebula is so large, it would take a human lifetime of watching to see even the slightest change in its shape. From our perspective, it remains frozen in a state of eternal elegant flight. The colors you will see, the soft violets, the glowing oranges, and the pale whites, are the signatures of different elements being cast back into the universe. Nitrogen, oxygen, and helium are all being breathed out, lighting up as they collide with the radiation from the white-hot core. It is a masterpiece of cosmic symmetry, a reminder that even in the final moments of a star's life, there is an inherent order and beauty. But while the butterfly and the helix represent the gentle deaths of stars similar to our sun, the universe also holds remnants of a much more dramatic nature. Not every star goes quietly into the night. Some end their journey with a sudden, brilliant flash that can outshine entire galaxies. As we leave the graceful wings of the butterfly behind, the silence of space begins to feel a bit more energized. We are moving toward a place where the threads of gas are not smooth, but tangled and wild, the glowing, jagged heart of a supernova remnant. As we drift through the silent dark, a new light begins to emerge. It doesn't have the smooth, flowing curves of the butterfly. Instead, it looks like a delicate web of glowing lace, or perhaps a tangle of colorful silk threads caught in a soft breeze. This is the Crab Nebula, one of the most famous and studied objects in the entire night sky. It sits in the constellation of Taurus, appearing to us as a beautiful, jagged ghost of a star that no longer exists. Imagine looking up at the night sky nearly 1,000 years ago. In the year 1054, astronomers in China and the Arab world noticed something extraordinary. A new star had suddenly appeared. It was so incredibly bright that it could be seen during the day for nearly 3 weeks, and it remained visible to the naked eye at night for almost 2 years. They called it a guest star, a mysterious visitor that had come to grace the heavens for a brief moment in time. What they were witnessing was the spectacular end of a star much larger than our sun. When such a massive star runs out of fuel, it can no longer support its own weight. It collapses inward in an instant, and then rebounds in a colossal explosion called a supernova. The Crab Nebula we see today is the expanding debris from that ancient event, a shell of gas and dust still moving outward into the void. At the very center of this chaotic, colorful cloud, something incredible remains. It is not a star as we know it, but a pulsar. This is a neutron star that has been crushed so tightly that it is only about the size of a small city. Yet it weighs more than our entire sun. This tiny, dense remnant spins 30 times every second, acting like a cosmic lighthouse. As it spins, it sends out rhythmic pulses of energy that ripple through the nebula, causing the surrounding filaments of gas to glow with vibrant greens, blues, and deep reds. The nebula is still growing, stretching outward at a staggering speed of about 900 miles per second. Within these tangled threads, the intense heat and pressure of the original explosion created something precious. It was in this moment of extreme energy that the universe forged heavy elements, the building blocks of everything we know. The silver in a precious coin, the copper in a wire, and the heavy metals deep within the earth were all born in the hearts of dying stars and scattered by explosions just like this one. It is a thought that brings a sense of quiet wonder to the mind as you settle deeper into your pillows. These distant glowing clouds are not just beautiful sights to behold, they are the workshops of the universe. As we linger here, watching the Crab Nebula's delicate threads shimmer in the distance, we begin to realize a profound truth. The vastness of space is not separate from us. We are drifting now toward a deeper understanding of this connection, moving from the grand scale of the cosmos to the very essence of our own existence. We are beginning to see that the story of the stars is, in many ways, our own story. It is a humbling thought, isn't it? As you lie there, feeling the soft weight of your blankets, you might find comfort in knowing that you are not just an observer of these celestial clouds. You are, in the most literal sense, made of the same stuff as the stars. The universe is a master of recycling, a cosmic gardener that never lets anything go to waste. When a star reaches the end of its life and releases its layers back into the void, it isn't a final ending. It is a gift to the future. This process, which scientists call nucleosynthesis, is the way the universe builds the complexity required for life. Think for a moment about the iron that flows through your veins, carrying oxygen to every part of your body as you take a slow, deep breath. Or consider the calcium that gives strength to your bones. Where did these elements come from? They weren't there at the very beginning of time. In the first moments after the Big Bang, the universe was filled with only the simplest, lightest gases, mostly hydrogen and helium. These gases are the raw materials, the basic building blocks, but they are not enough on their own to build a world or a person. To create something as heavy and solid as iron, the universe needed a forge of unimaginable power. That forge was the core of a massive star, burning at temperatures of millions of degrees. For eons, these stars fused lighter atoms into heavier ones, building the periodic table one element at a time. And when those stars finally reached their spectacular conclusions, they scattered those newly minted elements across the galaxy, seeding the very clouds of gas we have been exploring. Every atom of oxygen you breathe in this very moment was once part of a star's fiery heart. Every bit of carbon in your body, the very foundation of your life, was forged in a celestial furnace billions of years ago. As Carl Sagan famously said, we are made of star stuff. It is a poetic thought, but it is also a profound scientific truth. The atoms that make up your hands, your eyes, and your heart are ancient travelers. They have drifted across light years, endured the freezing cold of deep space, and been gathered together by gravity to form the world you know. Your body is a collection of fragments from stars that lived and died long before our own sun was even born. Knowing that we carry the legacy of the stars within us can make the vastness of space feel a little more like a home. It is a peaceful realization that we are part of a grand eternal cycle of renewal. Nothing is ever truly lost. It is simply reshaped into something new. As we continue our slow rhythmic drift through the velvet dark, we leave the remnants of the Crab Nebula behind. We are floating now toward another sanctuary in the stars, a place that feels like a tranquil oasis in the constellation of Sagittarius. Ahead of us, a vast, glowing pool of light begins to emerge from the darkness. It is the Lagoon Nebula, a place of quiet depths and hidden wonders, where a small, shimmering feature known as the hourglass waits to be discovered. As we drift closer to the Lagoon Nebula, the atmosphere of our journey changes. The chaotic energy of the supernova remnants fades, replaced by a profound sense of stillness. If the universe were an ocean, this would be a sheltered cove far from the crashing waves of more violent regions. It is a place of deep, resonant beauty, bathed in a soft, rose-colored glow that seems to pulse with a slow, steady heartbeat. Imagine, if you will, standing on an interstellar beach. Here, the sand beneath your feet is composed of microscopic silicate dust and frozen crystals, and the water is a vast, shimmering pool of ionized hydrogen. The Lagoon Nebula, or Messier 8, is one of the few star-forming regions visible to the naked eye under a truly dark sky. It sits within the constellation of Sagittarius, nestled in the densest part of the Milky Way's glowing band. To look toward it is to look toward the very heart of our galaxy. You might wonder why such a celestial wonder carries the name of a terrestrial body of water. The reason reveals itself as we gaze into its structure. Cutting through the center of the glowing pink gas is a wide, dark lane of dust. In a small telescope, this silhouette looks like a calm, dark channel of water winding through a bright landscape. It creates the illusion of a quiet lagoon, a peaceful waterway carved out of the stars. This dark lane isn't an empty void. It is a dense wall of cold gas and dust, so thick that it blocks the light from the stars behind it, creating a shadow that gives the nebula its iconic name. It is a place where the light and the dark dance in a slow, eternal embrace. At the very heart of this lagoon lies a feature of intense focus and beauty: the Hourglass Nebula. This isn't a separate object, but a small, incredibly bright region within the larger cloud. It is shaped by the ferocious energy of a young, massive star called Herschel 36. This star is 200,000 times more luminous than our sun, and its radiation carves out a cavity in the surrounding gas, twisting it into the shape of a delicate hourglass. It is a reminder that even in the quietest sanctuaries, the process of creation is active and powerful. Yet, from our distance, it looks like nothing more than a soft, glowing lantern in the dark. The Lagoon Nebula is vast, spanning about 110 light-years across. To put that in perspective, if our entire solar system were the size of a single grain of sand, the Lagoon Nebula would be larger than a professional football stadium. It is a massive nursery currently cradling hundreds of newborn stars, each one a tiny spark of light beginning its long journey through the cosmos. As you visualize this, feel the weight of your body settling further into your bed. As grounded and stable as the stars are vast, as you rest here, observing the ripples of gas and the soft shadows of the dust lanes, you might feel a sense of wonder at how we can see these details at all. These clouds are trillions of miles away, hidden behind layers of cosmic debris. We are able to witness this beauty only because we have learned to build incredible tools, eyes that can see what the human eye cannot. We are beginning to move beyond the limitations of our own vision, peering through the veils of gas to see the secrets hidden within the deep, dark folds of the cosmic nursery. To see the invisible, we have had to change the way we look at the universe. The eyes of humanity have grown sharper and more patient over the centuries, allowing us to peer further into the darkness than ever before. To truly understand the nurseries of stars, we have had to look past the limits of our own biology. Imagine, if you will, a magnificent golden sentinel floating in the eternal silence of space, far beyond the reach of the moon. This is the James Webb Space Telescope, perhaps the most sophisticated set of eyes ever built by human hands. It does not sit in a close orbit around our planet like the satellites we use for communication. Instead, it rests nearly 1 million miles away at a special quiet spot in space called the second Lagrange point, or L2. Here, it is balanced perfectly between the gravity of the Earth and the Sun, hanging in a stable, frozen pocket of the void. It stays there, tucked away in the shadows, keeping itself incredibly cold, so it can sense the faintest whispers of heat from the distant past. You might wonder why we need such a complex machine when we already have the wonderful images from telescopes like Hubble. The answer lies in the nature of light itself. Most of what we see with our own eyes is visible light, which is easily blocked by the thick, soot-like dust found in nebulae. It is like trying to look through a heavy fog or a thick curtain of smoke. But the James Webb Space Telescope sees in infrared. Infrared light is essentially heat, and it behaves differently than the light we are used to. Because infrared light has longer wavelengths, it doesn't bounce off the tiny grains of cosmic dust. Instead, it glides right through them, much like how a long rolling ocean wave can pass over a small rock without being disturbed. By capturing this invisible light, the telescope can peel back the dusty veils of a nebula to reveal the glowing baby stars hidden deep inside, stars that would otherwise remain invisible to us forever. To catch this delicate ancient light, the telescope uses a stunning primary mirror made of 18 hexagonal segments, arranged like the golden honeycomb of a celestial hive. These mirrors are coated in a layer of real gold, thinner than a human hair, but incredibly effective at reflecting infrared rays. As you drift deeper into relaxation, imagine this golden flower unfolding in the dark, miles away from any noise or interference. It is a silent observer, watching the universe breathe. While the Hubble Space Telescope gave us the vibrant, colorful clouds we have come to love, Webb allows us to see the skeleton of the cosmos, the heat of forming planets, and the very first sparks of light that ever flickered in the dark. With these new eyes, we are now able to look at familiar places in an entirely different way. One such place is a region of space so vast and so violent that it was once a blurry smudge of light, even to our best instruments. But through the golden mirrors of the James Webb, it transforms into a landscape of incredible detail. We are turning our gaze toward a distant neighbor, a place where star birth happens on a scale that dwarfs anything in our own Milky Way. Let your mind wander now toward the Great Magellanic Cloud, where a monstrous structure known as the Tarantula Nebula awaits. Through the infrared lens, we can finally see the true power of this cosmic giant, shimmering with the light of thousands of stars that were once hidden in the shadows. The Tarantula Nebula is a place of sheer, breathtaking power. Even its name, inspired by the long, spindly filaments of gas that stretch out like the legs of a giant celestial spider, suggests a scale that is difficult for the human mind to grasp. While we have explored many beautiful clouds within our own Milky Way to find the tarantula, we must look further out across the dark river of space to a neighboring galaxy called the Large Magellanic Cloud. This nebula, officially known by the catalog name 30 Doradus, is the most active star-forming region in our entire local neighborhood of galaxies. It is a cosmic factory operating on a scale that dwarfs almost everything else we know. If the Orion Nebula, which we visited earlier in our journey, were placed at the same distance from Earth as the Tarantula Nebula, it would look like a small, faint smudge. But if the Tarantula Nebula were as close to us as Orion is, it would be so large and so bright that it would cover half of our night sky, casting visible shadows on the ground, even in the middle of the night. It is a monstrous structure, stretching over 1,000 light years from one side to the other. To cross it at the speed of light would take a millennium, yet in the grand silence of the cosmos, it hangs perfectly still, a frozen explosion of light and dust. You might wonder why this particular region is so much more active and violent than the nurseries in our own galaxy. The answer lies in the restless nature of the universe. The Large Magellanic Cloud is a satellite galaxy caught in a slow gravitational dance with our Milky Way. As it orbits us, the gas within it is compressed and churned by the invisible hands of gravity. This constant stirring causes the gas to clump together much faster and more intensely than it does elsewhere. It is like a great ocean being whipped into whitecaps by a steady wind. At the very heart of this glowing web lies a cluster of stars known as R136. This is not just a regular group of stars. It is a collection of giants. Some of the stars within R136 are among the most massive ever discovered, with some weighing more than 200 times as much as our sun. These stars are so hot and so energetic that they are literally carving out the nebula from the inside, their intense radiation pushing the gas away and creating the vast hollowed-out caverns and ridges we see through our telescopes. Even as we contemplate this immense energy and the birth of these heavy giants, take a moment to notice the stillness of your own surroundings. The stars in the Tarantula Nebula are millions of miles apart, and the gas is thinner than a whisper. From this distance, the chaos of star birth becomes a peaceful, silent glow. Let your mind drift back to the feeling of your own breath, slow and steady. Like the vast, quiet reaches between galaxies, there is a profound peace in the stillness. You are safe, tucked away from the reach of these distant suns, resting in the cool, dark comfort of the present moment. Feel the soft weight of your body as it settles further into the mattress, letting the immense scale of the universe act as a protective blanket, reminding you how small and quiet your worries are in the face of such eternal beauty. We are moving now away from the heavy giants of the tarantula, drifting back toward the delicate, wispy structures that decorate our own galactic home. As we glide through the void, let the silence guide you deeper into rest, knowing that the same laws of physics that build these great nebula are the ones that keep our world turning night after night. As we leave the heavy density of the tarantula behind, we find ourselves drifting towards something far more ethereal, returning to the familiar stars of our own Milky Way. In the constellation of Cygnus, the Swan, there is a structure that looks like a tangled thread of silver and blue silk floating in the dark. This is the Veil Nebula, and it is perhaps one of the most delicate sights in the entire night sky. It does not look like a cloud so much as a collection of glowing ribbons or the wispy, translucent filaments of a spider's web caught in a soft breeze. These filaments are incredibly thin, appearing as fine as a strand of hair against the velvet of space. You might wonder how something so fragile and slender can be visible to us at all across the vast distances of the galaxy. The secret lies in its history and its immense scale. This delicate lace is not a nursery, but a ghost. It is the outer shell of a massive star that exploded in a supernova roughly 20,000 years ago. When that star reached the end of its life, it released a shock wave that began racing outward, plowing into the cold gas and dust of the interstellar medium. What we see today as the veil is that shock wave hitting the surrounding gas, heating it up until it glows with a soft, haunting light. Even though these threads look thin, they are part of a much larger structure known as the Cygnus loop. If you were to look up at the night sky and could see the entire nebula with your naked eye, it would cover an area about 3 degrees across. To put that in perspective, that is roughly 6 times the diameter of a full moon. It is a massive, expanding bubble of debris, and we are simply seeing the edges of that bubble where the gas is most concentrated. Even now, 20 millennia after the initial event, the shockwave is still traveling outward at a staggering speed of over 600,000 miles per hour. Yet, because space is so vast, this movement is invisible to us. From our vantage point, the veil remains perfectly still, a frozen moment of ancient power, transformed into quiet beauty. Take a slow, deep breath and let the image of these silver ribbons settle in your mind. Just as the shock wave moves through the silence of space without a sound, let your thoughts move through your mind without effort. There is no rush, no noise, only the slow accession of light. The veil reminds us that even the most violent events in the universe eventually settle into a state of profound peace and intricate grace. As we drift further along the swan's wing in the constellation of Cygnus, the wispy threads of the veil begin to fade into the background, and the cosmic landscape shifts once more. We are moving toward a region where the gas and dust begin to gather into shapes that feel strangely familiar to the human eye. We are leaving the abstract ribbons behind and floating toward a vast cloud that looks remarkably like a map of a distant home as we prepare to explore the North American Nebula. Feel yourself drifting closer, safe and warm as the shapes in the stars begin to emerge from the shadows. As we drift deeper into the constellation of Cygnus, you might feel a sudden, soft sense of recognition. It is a common human experience to lie on a grassy hill, watching the white clouds of Earth drift across a summer sky, finding the shapes of animals, faces, or distant lands in their fluffy edges. This phenomenon is called pareidolia, a gentle quirk of the human mind that seeks out familiar patterns in the randomness of nature. In the vastness of the cosmos, we do the very same thing. Before us now lies a cloud of glowing hydrogen gas so strikingly familiar that it bears the name of a continent, the North America Nebula, known to astronomers as NGC 7000. To the eye, the resemblance is uncanny. You can see the distinct curve of the Gulf of Mexico, the sharp point of Florida, and the long stretch of the East Coast. It feels as though a celestial map has been etched into the a mirror of our own world floating in the void. But why does it take this shape? Is there a hidden architecture to the universe that mirrors our own geography? The scientific truth is perhaps even more poetic in its simplicity. The shapes we see are the result of sheer, beautiful randomness. They are sculpted by the chaotic turbulence of interstellar winds, the invisible pressure of starlight, and the thick, dark curtains of dust that happen to sit between us and the glowing gas behind them. If we were to travel to a star system on the other side of this nebula, the continent would vanish. From a different angle, it might look like a dragon, a wave, or nothing at all. Our perspective from Earth is a unique, fleeting gift, a specific alignment of light and shadow that exists only for us. Within this nebula, there is a particularly bright and dense ridge known as the Cygnus Wall. This is a spectacular concentration of gas and dust, a cosmic rampart spanning about 20 light years. It is illuminated by the hidden stars within, glowing with a fierce internal heat that erodes the edges of the cloud into jagged mountainous peaks of light. It is a place of constant creation, where the raw materials of the universe are being forged into new suns. Just a short distance away, separated by a dark lane of dust that looks like a coastal shadow, is another cloud known as the Pelican Nebula. Together, they form one massive complex of gas, but from our vantage point, they look like two distinct neighbors in the sky. The Pelican, or IC5070, seems to follow the North America Nebula like a silent companion. Its beak actually a stream of ionized gas being carved out by the radiation of nearby massive stars. Take a moment to let your eyes rest on these cosmic shapes. Just as your mind finds order in the stars, let your body find its own natural rhythm of rest. There is a deep comfort in knowing that even in the unimaginable scale of the universe, we find things that remind us of home. The gas and dust are not trying to be a map or a bird. They are simply existing, drifting, and glowing in the dark. As the North America Nebula begins to recede into the distance, the shores and walls of gas softening into a warm, indistinct glow, we turn our attention toward another familiar form. We are moving away from the maps of the North and toward a structure of delicate circular symmetry. It is a nebula that looks less like a continent and more like a gift from a quiet garden, a vast red bloom opening its petals in the silence of space. Let yourself float toward the Rosette Nebula, the cosmic flower of the heavens, where the light becomes even softer and the air of the vacuum feels even more still. As we approach the Rosette Nebula, the darkness of the Monoceros constellation is gently broken by a deep, resonant crimson. It appears before us like a vast celestial rose, its petals of glowing gas unfolding across the blackness of space. This is not just a random cloud, it is a masterpiece of symmetry and color, a botanical wonder of the cosmos spanning about 130 light years across. If you were to look at it through a telescope, you would see layers of intricate filaments swirling and curling like the delicate edges of a bloom. At the very heart of this cosmic flower sits a cluster of brilliant young stars, known to astronomers as the Satellite Cluster, or NGC 2244. These stars are the reason the nebula exists in its current, breathtaking form. They are hot, blue, and incredibly energetic, having been born from the very gas that now surrounds them. But as your eyes drift toward the center of the nebula, you might notice something curious. The flower has a hollow center. It is not a solid disk of light, but rather a ring, an empty eye, looking back at us from 5,000 light years away. You might wonder what could have cleared away such a massive amount of material from the center of this cloud. The answer lies in the quiet power of starlight itself. The young stars in the central cluster are so massive and so bright that they produce intense radiation and powerful stellar winds. Think of these winds not as a gale you would feel on Earth, but as a steady, relentless pressure of particles streaming outward at millions of miles per hour. Over hundreds of thousands of years, this pressure has acted like a soft but persistent broom, pushing the leftover gas and dust away from the center, carving out a hollow bubble and piling the material up into the dense, red walls that form the petals. Take a slow, deep breath and imagine the scale of this structure. Despite its delicate appearance, the Horsehead Nebula is a heavy giant. It contains enough matter to create 10,000 stars like our sun. It is a massive nursery, still in the process of birthing new worlds along its outer edges, where the gas is being compressed by that central pressure. Even though it is 5,000 light years away, a distance so vast it is difficult to truly grasp, it feels intimate, like a quiet garden tucked away in a corner of our Milky Way. Let the warmth of that deep red light wash over you. There is a profound stillness here, even amidst the constant pushing and pulling of gravity and light. The Horsehead reminds us that even in the chaos of creation, there is a natural tendency toward beauty and order. The stars and the gas work together in a slow, rhythmic dance that lasts for millions of years. As we linger here, watching the soft glow of the petals, we begin to realize that our galaxy is a crowded, busy place, filled with these pockets of light and life. But the universe is far larger than the boundaries of the Milky Way. Beyond the reach of our galaxy's spiral arms lies a different kind of landscape, a vast, silent ocean of nothingness that stretches between the islands of stars. We are going to leave the comfort of the Horsehead now, drifting away from the familiar neighborhoods of our home galaxy. We are moving toward the lonely reaches of the deep voids, where we might find the intergalactic tramps, the solitary nebulae that drift far from any galaxy, existing in a quietude that most of the universe will never know. As we drift further away from the bustling neighborhoods of the Milky Way, the stars begin to thin out. The background turns from a crowded tapestry of light into a deep velvety black. We are entering the intergalactic medium, the vast, silent space that lies between the islands of galaxies. Here, in this immense emptiness, we find the intergalactic tramps. These are solitary nebulae, lonely clouds of gas and dust that exist far from the gravitational embrace of any galaxy. It is a strange and peaceful thought, isn't it? To imagine a cloud of potential stars just floating in the dark, millions of light years away from the nearest sun. These nebulae are the ultimate wanderers of the cosmos. In the silence of the void, they drift without a home, illuminated only by the faint distant glow of entire galaxies that look like tiny soft smudges of light on the horizon. You might wonder how these clouds ended up so far from home. In the universe, nothing is ever truly still. Galaxies are constantly moving, dancing around one another in a slow-motion ballet that takes billions of years. Sometimes, two galaxies pass too close to each other. When this happens, their immense gravity acts like a tidal force, reaching out and pulling long tails of gas and stars out into the void. This process is known as tidal stripping. While some of that material eventually falls back into one of the galaxies, some of it is cast off entirely, left to wander the intergalactic space forever as a quiet, orphaned cloud. There is also a process that astronomers sometimes describe as a galaxy breathing. When many massive stars explode as supernovae within a galaxy, they create a collective pressure so strong it can actually blow gas right out of the galactic disk and into the surrounding space. It is a slow cosmic exhale, sending material out to seed the intergalactic medium. This medium, the space between galaxies, is the most perfect vacuum we know of. It is incredibly sparse, with perhaps only one single atom of hydrogen in every cubic meter of space. Despite being so empty, this gas can be surprisingly hot, sometimes reaching millions of degrees, though it is so thin you would never feel its heat. It is a ghostly, invisible ocean that connects all the galaxies in the universe like a delicate cosmic web. Take a moment to appreciate the profound quiet of these lonely wanderers. There is no urgency here, no crowded clusters of stars to disturb the peace, just the slow, steady drift through the infinite dark. It is a reminder of how much of the universe is still waiting, still quiet, and still mysterious. But as peaceful as the void is, there is a certain comfort in the familiar. We begin to turn our gaze back toward the glowing spiral of our own home. We are traveling back toward the Milky Way, drawn by the familiar light of its 100 billion stars. As we approach the outer rim of our galaxy, we see a dark, jagged line cutting through the center of the starlight. We are moving toward the Great Rift, a place where the light of the galaxy seems to disappear into a deep, mysterious shadow, a dusty highway that leads us home. As we glide back into the embrace of our home galaxy, the Milky Way reveals itself in all its quiet majesty. From a distance, it looks like a luminous river of silver and gold, but as we draw closer, we see its most striking feature, a deep, dark, jagged line that seems to tear the galaxy in two. This is the Great Rift. It looks like a silent river of shadow flowing through a sea of light, a path of darkness that follows the curve of the galactic disk. For centuries, early observers looked up at this band and wondered if it was a hole in the heavens, a place where the stars had simply run out, leaving nothing but the empty, black vacuum of the beyond. But as we drift into its edges, we realize the truth is quite the opposite. This isn't an absence of matter. It is a profound abundance of it. The Great Rift is a massive collection of overlapping dark nebulae, cold clouds of molecular gas, and interstellar dust, so dense and so vast that they act like a heavy velvet curtain. They are the dusty highway of our galaxy, stretching across the sky from the constellation of Cygnus, all the way down to the bright regions of Sagittarius. In the region of Cygnus, Where the rift is particularly wide, it is often called the Cygnus Rift. It is a humbling thought to realize that this dust is the only thing standing between us and the true brilliance of the Milky Way's core. If these dark clouds were not there, the center of our galaxy would shine so brightly in our night sky that it would cast visible shadows on the ground at night, equaling the glow of a full moon. Instead, the rift keeps that light hidden, preserving the soft, peaceful dimness of our nocturnal world. As we travel through this corridor of shadow, the dust feels less like an obstacle and more like a protective blanket. These clouds are the storehouses of the galaxy, holding the raw hydrogen and carbon that will eventually collapse to form billions of new suns and planets. It is a quiet, dormant place, a nursery waiting for the right moment to wake up. We are moving along this highway now, letting the darkness guide us toward one of the most famous neighborhoods in the sky. The shadows here are not uniform. They twist and swirl in the wake of passing stars, creating intricate patterns that look like smoke caught in a still room. We are approaching the region of Orion, where the dark clouds of the rift begin to meet the light of giant, newborn suns. Nestled just beside the easternmost star of Orion's famous belt, the darkness is beginning to change. A soft, flickering radiance is starting to bleed through the charcoal-colored dust, looking like the distant glow of a campfire on a cold winter night. We are drifting toward the Flame Nebula, where the light of a hidden star is finally beginning to peel back the shadows. As we drift closer, the flickering light becomes clearer, revealing the warm amber heart of the Flame Nebula. It is a sight that feels strangely familiar, like looking into the embers of a hearth after a long day. In the vast, cold vacuum of space, this cloud of gas and dust glows with the hues of a sunset: deep oranges, soft yellows, and rich, burnt sienna. But what makes the flame truly remarkable is the intricate network of dark branch-like veins that stretch across its glowing face. These are lanes of cold, thick dust, silhouetted against the light behind them, looking like the charred remains of a forest or the delicate skeleton of a winter leaf. You might find yourself wondering what could possibly light such a massive flame in the middle of the dark. In the silence of the cosmos, there is no oxygen to feed a fire and no wood to burn. The secret lies just to the side of the nebula, in a star of incredible power. This is Alnitak, the easternmost star in the famous belt of Orion. Alnitak is a blue supergiant, a massive and brilliant sun that pours out a staggering amount of energetic ultraviolet light. Even though it sits some distance away, its radiation is so intense that it reaches out and touches the cold hydrogen gas of the nebula. This process is a gentle one called ionization. The ultraviolet rays from Alnitak strike the hydrogen atoms within the cloud, knocking their electrons away. As those electrons eventually settle back into place and recombine with the atoms, they release energy in the form of light, that soft, warm glow we see from our vantage point. It is a celestial neon sign powered by the energy of a distant neighbor. Cataloged by astronomers as NGC 2024, the Flame Nebula is more than just a beautiful light show. If we were to peer through the dust with infrared eyes, we would see that the flame is actually a busy nursery. Deep inside the thickest parts of the cloud, a cluster of hundreds of young stars is being born, many of them still hidden from our view by the very dust that gives the nebula its shape. There is a profound peace in this glowing cloud, a sense of warmth that belies the freezing temperatures of the surrounding void. It reminds us that even in the darkest reaches of the galaxy, there are places of light and creation, quietly working through the eons. We linger here for a moment, watching the way the dark dust lanes seem to dance against the golden backdrop before we begin to turn our gaze away. Our journey now takes us toward a different kind of wonder, a place where three distinct worlds of light and shadow meet in a single magnificent structure. We are moving toward the Horsehead Nebula, the three-lobed jewel of the southern sky. As we drift further through the velvet dark, we come upon a sight that feels like a rare celestial coincidence. Imagine, if you will, three different wonders of the universe all resting in the same quiet corner of space. This is the Horsehead Nebula, a name that comes from the Latin word for split into three lobes. It is a triple-layered masterpiece, a place where different laws of light and matter converge to create something truly unique. In most parts of the sky, you might find one type of nebula at a time, perhaps a glowing cloud of gas or a cool reflection of starlight. But the Horsehead is special because it brings them all together. It is an emission nebula, a reflection nebula, and a dark nebula, all woven into a single tapestry. On one side, there is a soft, glowing pink created by the energy of young stars. On the other, a serene, ethereal blue where light from nearby suns bounces off microscopic grains of dust, and cutting through it all are the shadows. You might wonder why it appears so distinctly divided, as if someone had carefully partitioned the cloud into sections. When you look closely at the pink heart of the nebula, you see three dark lines that meet in the center, like the petals of a flower or the spokes of a wheel. These aren't gaps in the gas, but rather dense, cold lanes of dust. These dark nebulae sit right in front of the glowing pink background, blocking the light and creating the illusion of a divided cloud. It is a game of perspective, a silhouette of cosmic proportions that gives the Horsehead its iconic shape. Astronomers call this beauty Messier 20. If you were to look for it from Earth, you would find it in the constellation of Sagittarius, resting in a region of the sky often called the steam rising from the teapot. It is a fitting place for such a soft and airy wonder. The contrast between the warm pinks and the cool starlight blues makes it one of the most photographed objects in the night sky, yet it remains perfectly silent and still, tucked away 5,000 light years from our home. The pink light comes from hydrogen gas being heated to thousands of degrees, while the blue light is the result of scattering, much like the way our own sky on Earth turns blue during the day. Take a slow, deep breath as you imagine this pink and blue flower floating in the distance. The Horsehead reminds us that even in the vastness of space, there is a sense of order and delicate beauty. We are beginning our slow descent now, turning our gaze back toward the more familiar reaches of our galaxy. The great, sprawling clouds are starting to give way to more focused wonders, smaller pockets of light that show us the incredible power of a single star. We are drifting toward a phenomenon that looks almost like a fragile soap bubble, floating undisturbed in a dark room. As we drift further, we encounter an object that seems impossibly delicate, a shimmering translucent sphere known as the Bubble Nebula. In the vast chaotic landscape of gas and dust we have traversed, This perfect circle stands out like a masterwork of geometry. It looks almost like a soap bubble caught in a gentle breeze or a marble of glass resting against a dark velvet cloth. But this is no toy. It is a testament to the immense power of a single star and its interaction with the cold, dark matter of space. At the heart of this sphere, slightly off-center, lies a star that is truly a giant. This star is roughly 45 times more massive than our own sun. It is young, hot, and incredibly energetic. As it burns through its nuclear fuel, it releases a fierce stream of charged particles known as a stellar wind. This wind moves outward at millions of miles per hour, acting like a cosmic leaf blower. It pushes against the surrounding cold gas of a much larger molecular cloud, carving out a hollow, spherical space. You might find yourself wondering why this bubble doesn't simply pop or dissipate into the void. In our world, a bubble is a fleeting thing, easily broken by a touch or a gust of wind. But in the vacuum of space, the bubble nebula, scientifically labeled as NGC 7635, is held in a state of magnificent, steady tension. It doesn't pop because the pressure from the star's wind is constantly pushing outward, while the dense, cold gas of the molecular cloud pushes back, containing the expansion. It is a delicate balance of forces, a standoff between light and shadow that has lasted for thousands of years. The scale of this bubble is difficult to grasp. While a soap bubble on Earth might fit in the palm of your hand, this celestial sphere is 7 light years across. To put that in perspective, our entire solar system would be a tiny, invisible streak inside it. Light itself takes 7 years to travel from one side of the bubble to the other. Yet, despite its enormous size, it appears soft and fragile, glowing with a faint ethereal light as the star's radiation ionizes the gas, making it shiny with a gentle, ghostly hue. As you think about this perfect sphere, take a moment to notice your own breathing. Imagine that with every slow inhale, you're expanding like that cosmic bubble, calm, steady, and full of light. And with every exhale, you settle deeper into your pillows, feeling the support of the bed beneath you. The bubble is not a chaotic explosion. It is a slow, rhythmic expansion, a peaceful push against the darkness. It reminds us that even the most powerful stars can create shapes of incredible grace and symmetry. Let your mind rest on that image of the shimmering 7 light-year wide sphere. It is a quiet sanctuary in the constellation of Cassiopeia, a place where the fierce energy of a star is transformed into a symbol of serenity. We are watching it from a distance now, seeing it grow smaller as we begin to turn our focus away from these distant nurseries and back toward the familiar glow of our own corner of the galaxy. The great journey through the clouds is nearing its end, and we are preparing to return home, carrying the peace of the stars with us. We leave the shimmering sphere of the bubble nebula behind now, watching as its perfect symmetry fades into the distance, becoming just one more point of light in the vast tapestry of the constellation Cassiopeia. Our perspective begins to shift, turning away from the deep reaches of the interstellar medium and pointing back toward the familiar. We are beginning the long, quiet drift home as we move through the silent dark, take a moment to reflect on the journey we have taken together. We have traveled across thousands of light years, witnessing the magnificent cycle of the cosmos. We saw the dark, cold molecular clouds where gravity first began its slow, patient work, pulling gas and dust into the tight embrace that creates a star. We stood before the towering pillars of creation and watched as the first sparks of nuclear fusion cleared the cosmic fog. We saw the vibrant reds of hydrogen and the ethereal blues of reflected starlight, and we marveled at the ghosts of stars, the planetary nebulae and supernova remnants that scatter the seeds of life back into the void. In the stillness of this return journey, you might wonder what we have truly learned from these distant wonders. The answer is found in the very atoms that make up your body. The universe is not a collection of separate, lonely objects. It is a grand, eternal cycle of renewal. Every heavy atom within you, the iron in your blood, the calcium in your bones, the oxygen you are breathing right now, was forged inside the heart of a star or born in the heat of a cosmic explosion. You are quite literally made of stardust, a small piece of the universe that has become conscious and is now resting, safe and warm, on a small planet. Ahead of us, a familiar light begins to grow, casting a steady golden glow across our path. This is our sun. Compared to the massive, volatile stars we've seen, our sun is a picture of serene stability. It has been shining for about 4.6 billion years, currently in the calm middle of its long life. We live in a remarkably quiet stellar neighborhood, a peaceful harbor in the vastness of the Milky Way. Our sun isn't destined for a violent supernova. Instead, billions of years from now, it will gently expand and then shed its layers to create a beautiful planetary nebula, much like the ones we admired earlier. It is a graceful future, a quiet return to the clouds from which it was born. As we drift closer to the soft blue glow of Earth, the velvet black of space begins to transition. We pass through the thin, invisible layers of the exosphere, where the last few stray atoms of our atmosphere dance in the vacuum. The silence remains, but there is a growing sense of weight, a feeling of being pulled back to the ground. The colors around us begin to shift from the deep blacks of the abyss to the faint, dark violets and deep blues of the upper atmosphere. We are descending through the thermosphere and the mesosphere, moving through the protective blanket that keeps our world safe and warm. The vastness of the nebula is now a memory, replaced by the comforting, familiar pull of home. You are returning to the air, the gravity, and the stillness of your own room, carrying the peace of the stars back with you as you prepare to cross the threshold into sleep. The journey is complete now. You are back in the safety of your bed, the weight of the blankets pressing gently against you, grounding you in the present moment. If you open your eyes just a sliver, you might see the soft silver glow of the moon filtering through the window, casting long, quiet shadows across the room. The moon is our constant companion, a silent guardian that has watched over the earth for billions of years. Its light is a pale reflection of the sun, a reminder that even in the deepest night, we are never truly without the light of the stars. As you lie here, your mind begins to drift, and that is exactly as it should be. There is a concept in environmental psychology known as soft fascination. It describes the way our attention is captured by things that are pleasing and restorative, but not demanding. The rustling of leaves, the movement of water, or the slow, majestic expansion of a nebula. This gentle focus allows the directed attention part of your brain, the part that works so hard all day, to finally rest and recover. By journeying through the cosmos tonight, you have given your mind the space it needs to settle into its natural, quiet rhythm. Your body knows exactly what to do. Your circadian rhythm, the internal clock that has evolved over millions of years under the rising and setting of our sun, is signaling for deep rest. Soon, you will enter your first sleep cycle of the night. These cycles usually last about 90 minutes, carrying you through different stages of rest, from the light drift of initial sleep to the deep restorative stages where your body repairs itself and your mind organizes the wonders you have seen. It is a beautiful biological dance, as ancient and reliable as the orbits of the planets. Before you let go completely, take one last moment to check in with your body. Feel the back of your head resting against the pillow. Notice your jaw. Let it go slack, releasing any last bit of tension you might be holding in your face. Feel your shoulders melt into the mattress, heavy and relaxed, as if gravity is a warm hand pressing you down into safety. Let your hands rest naturally, the fingers curling softly, as still as the dust in a dark nebula. Your breath is a slow, steady tide now, rising and falling without effort, matching the pulse of the world around you. The universe is vast, but it is also home. You have traveled light years tonight, across cathedrals of gas and through the hearts of dying suns, only to find that the same peace exists right here in the quiet of this moment. The stars will continue their slow, ancient work while you rest. They will be there when you wake, and they will be there in your dreams, shimmering in the distance as they have for eons. You are safe. You are part of the cycle. You are made of the very light you have been watching. Close your eyes now. Let the darkness be a soft velvet blanket, protecting you and holding you close. There is nothing left to do but drift. May your dreams be as beautiful as the clouds of Orion and as peaceful as the silence between the stars. Sleep well. Good night.